my my major. I am postgraduate student, postgraduate fresh researcher, especially in bioinformatics major. All my job done at laptop, that's in silico aspect. I have many research from 2020 from year to now. But this year I focused on in silico perspective for new therapeutic inhibitor against SARS-CoV-2, RBD. RBDs actually variants, approaches to QSAR and molecular docking modeling. Professor, do you handling with a QSAR? I know that Professor Aquino handling with a QSAR before.
No.
Okay, that's a quantitative structure activity relationship. A relationship between the chemical structure with chemical properties and that's a relation between chemical structure with a chemical properties and activity, this chemical activity, to know how that effect of functional group of chemicals affecting on such an activity, on a laboratory activity or biological activity. That's research paper already have a first place award of Banha University, and between collaborative between Inchems University and Banha University, and published as a conference paper at United Research Forum. We know that coronavirus enters the cell using spike RBDs, interact with EC2, and coronavirus spike protein RBD variant many times to 7 variants such Omicron, Beta, Alpha, Gamma, Eta, Zeta variants. That's overall. These variants affecting on this variant affecting on two ways, affecting to treatment of coronavirus, such the variant on protein affecting the treatment or drugs of coronavirus, and affecting to vaccination of a coronavirus to be an effect to the virus after that. So we need to have screen all variants to have a drug for all variants, but it's difficult to develop a drug for variant per variant, because virus will develop and will evolve and will mutate over the time everywhere and every time. So it's difficult to have one drug. It's difficult to have a drug for each variant alone. And on other side, bacteria also evolved and mutate to be a superbug and MRSA, such Ahmad said before. So we need to have a universal inhibitor or universal drug or universal inhibitor antagonist for this target bacterial or for this or for this viral target. So what we do, we align all 7 corona variants RBDs to get the shared bucket here and here. Shared bucket. A bucket is active site that interact with ACE2. This shared place for all 7 variants. The yellow one is an Omicron. The orange one is a Beta. But all variants, all 7 variants, to get an interacting, the shared interacting place. This shared interaction place, we have in Egyptian market common drug called niclosamide. Niclosamide duck in this place to inhibit the interaction between ACE2 human receptor and RBD. That make some conformational change in protein to in such a protein to inhibit the interaction between them. That's a common drug called niclosamide. But niclosamide is not affected to be to an Omicron or Beta variant. Then we use AI, artificial intelligence, to generate nearby 80 compound fit with each variant RBD. After we align all 7 variants to get a shared bucket, we use artificial intelligence to have to get 80 compound per each bucket for them. So we have 300 or nearby 360 common drug by AI for this problem. And we perform a molecular docking for all of them, those compound with H7 variants, RBDs. Our findings that we have 2 places of coronavirus interaction with our drugs, and we have a common one for all 300 compounds or all 300 drugs. One common drug that's affecting with those buckets with a high affinity, binding affinity with those buckets above the standard one or above the reference one, that's niclosamide, that's in market, in Egyptian market, in 2 different buckets of spike. That's our binding or generated AI generated compound or generated drug interacting with RBD and ACE2 receptor. That's our impact of this synthetic accessibility and drug-like rules are most important measure for drug design. Our compound compatible with Lipinski. Lipinski's rule is the rules for a drug likeness of our compound, and our compound is have a yes for all Lipinski's rule, excepted by one, that's molecular weight of our compound and such rules. But we have a big problem, that's synthetic accessibility in lab is above 6 score, and that means that our compound is very hard to be censored in lab. That's our method. We use different databases and servers to have our compound. First, we retrieve all our proteins from RCSB, BDB protein data bank database, and then we get the shared bucket using server called DeepSight on Play Molecule platform. Then we put our dimensions of all 7 variants of DeepSight on ligand. Then ligand give us the 80 compounds, generated AI compounds that we perform docking on Autodock using Vienna virtual screening method. That's our method, but that's our result interacted amino acids, and the difference between our 4 compound, that's our generated AI compound or generated AI drug. The difference between the binding affinity or delta G between our generated compound and niclosamide, that's a reference of us, show the promising effect expected on the Kappa variant. Our result, that's our compound, and promising that no such a similar compound in database for our lead. But we use a Swiss ADM server to measure a synthetic accessibility of this compound is about 6.7, which is hard, but we cooperate with a French laboratory to make a retrosensus for this compound. That we have a scheme for sensing for this compound, and now it's easily to censor by this chemical biochemical reactions. That's retrosensor scheme. My another project that's present progress is a curcumin. It's already done as a graduation project for Ain Shams University. CRK the protein modeling. MOBO that's database for all proteins modeling of monkeypox, and then cell mutations for sugar cane resistant smut proteins, and RNA aptamer for HER breast cancer, and I done before aptamer design as in silico aspect for nematoda profilin protein, and the effect of the mutation based on drug design for 3CL protease. We make mutations for 3CL protease to get the effect of this mutation on 3CL protease, and then we will done the same project that we talk about to get the most effective drug that can affect on 3CL all variants that can be had. That's all my research done before, and I already published this research with my supervisor, Dr. Hussein Jalal, SAR and Q SAR COVID-19 main protease inhibitor interaction of recently X-ray crystallized complexes, and we already underpublished two wheelie that's NB3 that's nematoda profilin aptamer in silico perspective, and we have some. That's my graduation project, and that's my package that's already published on GitHub, and that's my presented, and this aim. That's my contact, and thanks you. Any query?